Open up with your books, page number 91, Invertible matrices. We should first understand what we mean by invertible matrices before trying to find out the inverse of any matrix. See, the definition is if A is a square matrix of order M and if there exists another square matrix of order, same order, such that AB is equal to BA is equal to I, means multiplying with A with B we are going to get I, or I multiply B with A we are also going to get I only. I means the identity matrix. Then B is called the inverse of A and it will be denoted by A inverse. In this case A is said to be invertible. If this exists, that AB is equal to BA is equal to I, then only we can say that it is invertible. Just see the example. We are taking here two matrices. A is 2, 3, 1, 2 and B is 2, minus 3, minus 1 and 2. These are two matrices. And we are going to find AB. I had put here A and a B and multiplying it. You know how to multiply it. First row, then this first column I multiplied it 2 into 2, 4, 3 into minus 1, minus 3. Similarly, the other terms, I am getting here 1, 1, 0, 0 means this is the value of I. This is identity matrix. Similarly, now I am multiplying this BA. Again I am going to get this I. So this means that AB is equal to BA is equal to I, or I can say that B is the inverse of A and A is the inverse of B. And we can write it like this. B is the inverse of A and A is the inverse of B. So B is equal to A inverse and A is equal to B inverse. Few points are there to remember. A rectangular matrix does not possess inverse matrix. Just we read the definition of invertible matrices. There it was clearly written it should be a square matrix. If it is a rectangular matrix, we cannot find the inverse. Since product BA and AB are not defined. When we cannot multiply it, we are saying that they are not defined for a rectangular matrix, so we cannot find the inverse also. Keep this in mind very clearly. Second point, if B is the inverse of A, then easily we can say that A is also the inverse of B. There are two theorems given in the book on page number 91 itself. Theorem number 3 and theorem number 4, you have to do it from your book only. Just I am going through it. See here. Theorem number 3 says uniqueness of inverse. Means inverse of any square matrix, if it exists, is unique. Means it will be just unique, means it will be only a single matrix which can be the inverse of any square matrix. There cannot be another matrix which will be the inverse. They had given a proof also here. And the theorem number 4 says if A and B are invertible matrices of the same order, then AB inverse is equal to B inverse A inverse. Right? So let's see this proof, theorem number 4. See here. From the definition of inverse of a matrix, we have that A inverse is equal to I. We are taking here a matrix AB. So it will be AB into AB inverse is equal to I. Now we are multiplying with A inverse both the sides. Here also I am multiplying with A inverse and on the other side also I am multiplying with A inverse. And taking this A inverse into A. This will become I. So this is now IB and this is AB inverse. This itself is A inverse into I. I is just treated as 1 only in matrices. So this is A inverse. Now what we are getting? IB. IB means multiplying with 1 we can get B. B AB inverse is equal to A inverse. Now again we are pre-multiplying with B inverse both the sides. This will be B inverse B and here it will become B inverse into A inverse. B inverse B will become I and here it is B inverse A inverse. I multiplied with AB inverse will again be the same thing AB inverse. So we can reach this conclusion that AB inverse is equal to B inverse into A inverse.